Welcome to the channel. Please consider subscribing. I produce videos daily that cover a wide variety of cloud topics, with a focus on networking. Let's analyze this VPN routing question. Your firm needs to configure two routes for two VPN connections between GCP and on-premises networks in an active-passive configuration. Active-passive means one connection is the primary, or active, connection that carries all traffic during normal operations. The second connection remains on standby as the passive connection, and only activates if the primary one fails. As the network engineer, you need to determine the correct routing configuration to achieve this failover behavior. The key is understanding how route priority works in GCP. Before diving into the options, let's understand the basics of GCP route priority. In Google Cloud, routes have a priority value, where lower numbers mean higher priority. This can be counterintuitive, but it's critical to remember. A priority of 100 is preferred over a priority of 1000. When multiple routes match a destination, GCP selects the route with the lowest priority number. For VPN connections, each tunnel gets a route. In an active-passive setup, we want the active tunnel's route to have a higher priority, which means a lower number, than the passive tunnel's route. This ensures traffic flows through the active tunnel during normal operations. Active-passive VPN architecture. Now let's look at how active-passive VPN should be configured. In this architecture, you have two VPN tunnels connecting your on-premises network to GCP, but they operate differently. The key is using route priorities. You create two routes to the same destination, your on-premises network, each pointing to a different VPN tunnel. The route with priority 100 points to VPN tunnel 1, making it the active path. The route with priority 1000 points to VPN tunnel 2, making it the passive backup. During normal operations, all traffic flows through the active tunnel because GCP always chooses the route with the lowest priority number. The passive tunnel remains established and ready but carries no traffic. This design provides high availability. If the active tunnel fails, traffic automatically switches to the passive tunnel within seconds. Let's analyze option A, which suggests creating one route for both connections with a priority of 1000. With the next hop as a single VPN tunnel. This doesn't make sense for several reasons. First, you can't have one route pointing to two different VPN tunnels. Each route needs a specific next hop. A route must specify exactly which tunnel to use. Second, even if this were possible, having the same priority for both wouldn't create active-passive behavior. It would create active-active with load balancing. This option shows a fundamental misunderstanding of how GCP routing works. It's technically impossible to implement. Option B proposes creating one route for each connection, but giving one route a higher priority. Remember, in GCP, a higher priority means a lower priority number. This is the correct approach for active-passive. For example, an active tunnel route with a priority of 100, and a passive tunnel route with a priority of 1000. During normal operations, traffic uses the priority 100 route, which is the active one. If that tunnel fails, GCP automatically fails over to the priority 1000 route, which is the passive one. This option correctly implements an active-passive VPN configuration and is the correct answer. Option C suggests creating one route for each connection with the same priority, with the next hop as the IP address of the connections. The first issue is that VPN routes use VPN tunnels as next hops, not IP addresses. You specify the VPN tunnel resource, not an IP. This is a fundamental error. The second issue is that the same priority creates an active-active configuration, not an active-passive one. Traffic would be distributed across both tunnels using ECMP, or equal cost multipath. This doesn't achieve the required active-passive configuration and uses an incorrect next hop type. Option D suggests giving one route a lower priority, with the next hop as IP addresses. Let's carefully analyze this wording. Lower priority in networking terminology typically means a higher priority number, which makes the route less preferred. So if one route has a priority of 100 and another has a lower priority, that would be something like a priority of 1000. This would actually create the correct active-passive behavior. However, the fatal flaw is specifying the IP address of the connections as the next hop. VPN routes in GCP must use VPN tunnel resources as next hops, not IP addresses. While the priority concept in option D would work for active-passive, the incorrect next hop type makes this option invalid. Let's examine failover behavior in a properly configured active-passive setup. During normal operations, the route with priority 100 is active, directing all traffic through Tunnel 1. When Tunnel 1 fails, GCP detects the failure, typically within 10 seconds, and removes that route from the routing table. The route with priority 1000 now becomes the best available path. Traffic automatically fails over to Tunnel 2 without any manual intervention. When Tunnel 1 recovers, its route is automatically reinstated with priority 100, and traffic fails back to the primary tunnel. This automatic failover and failback process provides high availability while maintaining a predictable traffic path during normal operations. Here are some best practices for implementing an active-passive VPN. Use significantly different priority values, like 100 versus 1000, to make the configuration clear. Monitor both tunnels. The passive tunnel should be up and ready, even if it is not carrying traffic. Test failover regularly to ensure it works as expected. Document your priority scheme, as teams often get confused about which tunnel is active. Consider using cloud VPN logs and metrics to track tunnel usage and failovers. Finally, for critical connections, you might also implement application-level health checks. Key takeaways. The correct answer is option B. Create one route for each connection but give one route a higher priority, meaning a lower number, with the VPN tunnel as the next hop. Remember these key points. Lower priority numbers mean higher preference in GCP. Each VPN tunnel needs its own route. Active-passive requires different priorities. VPN routes use tunnel resources as next hops, not IP addresses. The same priority creates active-active, not active-passive. Understanding these concepts is crucial for both the exam and real-world VPN implementations in GCP. Thank you for your attendance. Please consider subscribing to the channel.